This video is about application of derivative and integral kinematics. For the kinematics, we have displacement, velocity, and acceleration functions. This diagram shows the relationship between displacement, velocity, and acceleration. Derivative of displacement equals velocity. Displacement of velocity equals acceleration function. We can do that backwards. Velocity function equals integral of a of t. Then acceleration function equals integral of velocity function. You need to remember this. For this section, you need to know the difference of displacement and distance traveled. For the displacement, this is the formula. For the distance traveled, you have to do integral of absolute value of this velocity, absolute value. Let's go to guided practice 1. A car travels along a straight road with the velocity time function illustrated here. What's the significance of the graph above the t-axis? Above the t-axis means the velocity is positive. That means that's moving forward or moving to the right. If below the t-axis, which means the velocity is negative, so we could say this is moving backward. For B, find the total distance traveled by the car. As we know, the displacement function equals integral of velocity. In other words, the area of this, it will be the displacement. The area for this, you will get the displacement. But for this displacement, it will be negative. And this displacement is positive. Therefore, for the total distance, I will get the area of this trapezoid. That is 0.1, 0.3. Height is 60. The area for this trapezoid, you will get the 1/2. 0.1 plus 0.3, then times 60. Then we need to add the area of this trapezoid. Make sure this is positive. So we have 0.3, 0.1. The height will be 20. So we add 1/2. 0.1 plus 0.3 times 20. So we get 12 plus 4. You will get 16. Unit will be km. Now let's go to C. Find the final displacement of the car from its starting point. Let's use S stand for that. You will get still the area for this. It will be 1/2. 0.1 plus 0.3 times 60. Then you need to subtract the area of the trapezoid below t-axis. So we have 1/2, 0.1 plus 0.3 times 20. Your answer will be 12 minus 4 equals 8 km. Now let's go to guided practice 2. A particle has a velocity function this. As it moves in a straight line, the particle is initially 2 centimeters to the right of O. For the IB exam, some kinematics problem is not calculator based, like guided practice 2. Without graphing calculator, you have to make sure analyze the velocity. You have to do the sign diagram for the velocity so that you can working on the distance traveled. For A, write a formula for the displacement function. So S of t equals integral of velocity function. So we have 1 minus 2t dt. Using this formula, we will get 1t minus 2 times t squared over 2, then plus c. So we have t minus t squared plus c. According to the given information, the particle is initially 2 centimeters to the right of O, which means when t equals 0, S of 0 equals 2. So we plug into this function. You will get the 2 equals 0 minus 0 squared plus c. Therefore, c equals 2. In other words, I can find the function of displacement that equals t minus t squared plus 2. Let's go to B. Find the total distance traveled in the first second of motion. You have to draw the sign diagram for velocity function. So for the velocity equals 1 minus 2t, you will set up velocity equals to 0. So 1 minus 2t equals 0. You will get the t equals 1/2. And we draw sign diagram for the velocity. Here is 1/2. 0 is here. So we plug in 0 to this function. You will get the 1 minus 2 times 0 is a positive. So I will put this positive. For linear function, definitely you need to change the sign for this. So this will be negative. So I will draw here the 0. Then this will be 1. Therefore, for the distance, I can write down from 0 to 1/2. Velocity function dt, then minus. When velocity is negative, that means the displacement will be negative. That's why when you're looking for the distance, you have to do this subtraction. Then we do from 1/2 to 1. Velocity function dt. You will get t minus t squared. Using this, you don't have to add this constant number for this definite integral. So we do, this is from 0 to 1/2. Then minus, we have t minus t squared. Then it's from 1/2 to 1. When you plug in 1/2, you will get the 1/2 minus 1/2 squared. That is 1/2 minus 1/4 equals 1/4. When you plug in 0 will be 0, therefore you will get the 1/4. Then minus, when you work out this side, you plug in 1 first, you will get the 1 minus 1 squared. That equals to 0. Then when you plug in 1/2, we already know that's 1/4. For this 1/2. Therefore, you will get the 0 minus 1/4 equals negative 1/4. So minus negative 1/4. Negative negative will be positive. That's why you will get the 1/2. This will be the distance. Now let's go to C. Find the displacement of a particle at the end of 1 second. This displacement equals s sub 1 minus s sub 0. You can use this formula. So I get the 1 minus 1 squared plus 2. Then when you plug in 0, you will get the 2. So then minus 2. You will get 0. This is one way to do that. Or you can just do integral. Therefore, s of 1 equals integral of velocity function from 0 to 1. Then you will get the t minus t squared. Then from 0 to 1, you will get 0 minus 0 equals to 0. So if the problem is not calculator based, you have to do the sign diagram for the velocity so that you can work out the distance traveled. But if you have a graphing calculator, you can using this formula to get the answer directly from the graphing calculator. Guided practice 3 is still not calculator based. Particle P is initially at the origin, which means s of 0 equals 0. It moves with the velocity function this. Write down a formula for the displacement function. So we have displacement equals integral of velocity. So we have t squared minus 4t plus 3. We do integral equals. By using this formula, you will get for t squared, that is t to the third power over 3 minus 4 times t squared over 2 plus 3t, then plus c. We plug in s of 0 equals 0 so that you can get the c equals 0. In other words, s of t equals t third power over 3 minus 2t squared plus 3t. Simplify, this one will be 2t squared Look at the B. Find the total distance traveled in the first 5 seconds of motion. For the velocity, you will get the t squared minus 4t plus 3 factor t minus 1 times t minus 3. So we will get the roots t1 equals 1, t2 equals 3. You will get, this is 1, here's a 3. Then we plug in 0. That equals positive. So here is a positive. Since the exponent is a odd number, so we switch the sign for the neighbor interval. This will be negative, here is positive. We have 0 here. Therefore, for the distance that equals, you have to do from 0 to 1. Velocity dt. Then minus, because this is negative, which means displacement will be negative. That's the reason you have to do minus from 1 to 3, that integral velocity dt. This is a positive. That's why we do from 3 to 5. Because they ask you the first 5 seconds. Then you do velocity dt. Since we already got the integral of a velocity, that is this. So we get t to the third power over 3 minus 2t squared plus 3t. This will be from 0 to 1. Then minus a same function. You will get the t to the third power over 3 minus 2t squared plus 3t. Then from 1 to 3. Then plus t to the third power over 3 minus 2t squared plus 3t. We do from 3 to 5. For the first one, I plug in 1. You will get 1 over 3 minus 2 plus 3. So you get the 4 over 3. Minus 0. Because you plug in 0, it will be 0. Then we're working on this. We plug in 3. You will get the 27 over 3 minus 2 times 9 plus 3 times 3. This will be 9 minus 18 plus 9. That equals to 0. So minus, here's 0. I plug in 1. You will get 4 over 3. Then plus, I plug in 5 to this function. You will get 125 over 3 minus 2 times 25 plus 3 times 5 is 15. So you get the 125 over 3 minus 35. You will get the 20 over 3. So here's 20 over 3. Then you plug in this 3. We already got 0 here. Then minus 0. We will get 4 over 3 plus 4 over 3 plus 20 over 3. You will get the 28 over 3. That's the distance. Now let's go to C. Find the displacement of a particle at the end of 3 seconds. For this displacement, we will do S of 3 minus s of 0. Plug in 3, you will get 27 over 3 minus 2 times 3 squared plus 3 times 3. This is a s of 3. Then you need to minus, plug in 0. 0 to the third power over 3 minus 2 times 0 squared plus 3 times 0. You will get 0 minus 0 equals to 0. Or you can using this from 0 to 3 velocity times dt. You will get exactly the same answer. It will be 0.